In this video, we're going to look at an A-level question which involves calculating probabilities using the binomial distribution. Now, how do we know this question uses the binomial distribution? Well, the binomial distribution is used when we're looking at multiple sort of independent trials with two possible outcomes, sort of a pass or a fail. And in this case, what we're doing is we're dropping 10 tennis balls, and we're looking at pass or fail on a bounce test. So obviously those 10 tennis balls each being dropped, they're a random sample of balls previously used in professional tournaments. One ball doesn't affect another, so that's independent bounces. So what this is it's, let's say x equals the number of fails, then x has the binomial distribution. Well, the binomial distribution we say is BNP, where n is the number of trials and p is the probability. So in this case, x is distributed as b 10 trials, each with a probability of 0.15. Okay. So let's have a look at this question. We have to see if the number of balls which fail is at most 2. So at most 2, we're looking for the probability that x is less than or equal to 2, which is the probability that x equals 0, or the probability that x equals 1, or the probability that x equals 2. Now, how do I work out probabilities with the binomial distribution? Well, the key thing is that px is, let's do this in a different colour, px equals x is given by n choose x multiplied by p to the x multiplied by 1 minus p to the n minus x. So that's the way that we work out probabilities using the binomial distribution. So in our example, this is a formula we're just going to plug numbers into. So in our example, we have px equals 0, which is 10 choose 0 times 0.15 to the 0 times 0.85, that's 1 minus 0.15 to the power of 10. That's the px equals 0. And then plus 10 choose 1 times 0.15 to the power of 1 times 0.85 to the power of 9 plus 10 choose 2 times 0.15 to the power of 2 times 0.85 to the power of 8. And if you work out these numbers, we get 0.197 plus 0.347 plus 0.276, which is 0.820. So the probability of at most 2 balls failing the bounce test is 0.820. Okay. In part 2, it now asks for the probability of at least 2 balls failing. Well, what's the probability? What's at least 2 balls? Well, part 2, we now want p at least 2 balls. That means the probability that x is greater than or equal to 2. Well, that's the same as 1 minus the probability that x is 0, or sorry, 1 minus the probability that x is less than 2, which is 1 minus the probability that x equals 0 plus the probability that x equals 1. Well, probability x is 0, we worked out in part 1. That was 0.197. This is 1 minus 0.197. Probability x is 1, we also worked out in part 1. That was this 0.347 number. So we get 1 minus 0.197 minus 0.347, which is 0.456. The probability at least 2 balls fail the bounce test.